I welcome you once again for this series of talk on discrete Fourier transform. So far we have seen the formula for DFT, the need for DFT, what is IDFT. Then we have seen how to compute DFT by the formula method, and we noted that the calculations required for DFT are huge. There are a lot of calculations involved for computing DFT. Now there is another method which is called as a matrix method for computing DFT. So in this lecture we will be talking about this matrix method for computing DFT. But before going to the matrix method, let us try to understand some important concepts related to DFT. So this is the formula for DFT x of k, which we had previously seen, and this is called as the n point DFT because the length of the sequence is n. Okay, and we remember what is n and what is l. So if l is the given sequence, if l is a multiple of 4, l is a multiple of 4, then l and n are same. But when l is not a multiple of 4, you have to convert it into a multiple of 4 by padding the number of zeros. That is called as a zero padding, which we had seen in the previous numerical. So those who have not seen the previous videos, I request you to see the previous videos in order to understand the concept of capital N and capital L zero padding and how to compute the DFT. Okay, so this formula for IDFT is written like this: small x of n, that is a time domain sequence, x of k is given, that is the DFT is given. So remember this 1 upon n, it is divided by 1 upon n, and here the sign is minus, this is minus, and this is plus sign. Okay, so this is the difference between these two formulas. So these two formulas should be remembered very carefully. The signs have to be remembered carefully, and this 1 upon n is used for IDFT. Now in this case, this factor e raised to minus j by n, it is called as the Twiddle factor. So this is a very important factor which we call it as a Twiddle factor. So when we use this substitution Wn, so Wn it denotes the Twiddle factor. So Wn, if you substitute in this equation, so our this equation, which is a big equation, it will reduce to a small equation, capital summation n equal to 0 to n minus 1 x of n Wn nk. So Wn means what? E raised to minus j 2 pi by n. So instead of writing e raised to minus j 2 pi by capital N, we just write Wn, and here it is remaining nk, so we write here nk. So remember how this equation is written. So Wn nk. So in the subscript we are writing capital N, so this is e raised to minus j 2 pi by n, and in the superscript we are writing nk, small n and capital n and k. So when you add nk here, it will become e raised to minus j 2 pi nk upon n, which is same. So which is same like this. Okay, so instead of writing this, we just write Wn nk. Similarly for IDFT, it will be Wn minus nk. Why minus nk? Because here it is minus sign and here we have to have plus. So minus of minus will become plus. Okay, so that's why for IDFT it will be Wn minus nk, Wn minus nk, and for DFT it will be Wn nk. But here it is minus and here it is plus, so don't get confused about this minus and this plus. Wn here it is minus, so if when you write here Wn, automatically this negative sign is there, but when you write Wn minus nk, then we get the positive sign for this. Okay, so that's why remember this, don't write here Wn minus nk, so then it will be wrong. Okay, so these formulas you have to understand very well how the formulas are being written. Now this Twiddle factor, why it is called Twiddle factor and what are its important properties, we will see it shortly. Now this Twiddle factor is a periodic in nature. So one important property of Twiddle factor is that it exhibits a periodicity property. Okay, so periodicity property of Twiddle factor is used, and this is a very important property which will be used in fast Fourier transform algorithm. So here you can see W80. So this is repeating itself after an interval of 8. So 0, then 8, then 16, 32, 64, and so on. So all this will be repeated. Similarly, this will be repeated. So 1, again you add 8, so it will become 9. 9 plus 8 again, so it will be 17, and so on. So this exhibits a property called as periodicity. So Twiddle factor is periodic in nature. This is the first property. And second property is that it exhibits a symmetry property. Now what is this symmetry property? Let us try to understand. See, if I compute all the values of twiddle factor, suppose my twiddle factor value is for W8. Okay, so for W8, if I go on computing the value W8 0, 1, 2, 3, 4, 5 and 6. So how to compute this value? I can compute this value by using the formula, by using this formula. So what is my W8? Okay, so my W8 is, so in this formula if I write here, it will be W8 is equal to e raised to minus j 2 pi. So what is the value of n here? Capital 8, 8. So if I substitute here, it will be equal to e raised to minus j. So 2 4s are 8. So minus j pi divided by 4. Okay, so pi divided by 4. So how to compute this value? W8 e raised to minus j pi by 4. So now I can apply the Euler's formula. So cos pi by 4 minus sin pi by 4. So this will give me the value of W8. So similarly, you can go on computing the values. So you can compute the value of W8 0, then you put 1, W8 1, W8 2, W8 3 and so on. So if you compute W8 0, you will get the value as 1. When you compute W8 1, you will get the value as 1 upon root 2 minus j 1 upon root 2. So 1 upon root 2 is 0.707. So 0.707 minus 0.707 j. Similarly, W8 2 will be minus j. Then this value, then this value, then this value, then this value. So if you can see here, since it is a periodic function, okay. So since it is a periodic function, so if you rotate, if you go on computing this value, so here I get W8 0. So 0, 1, 2, 3, 4, 5, 6, 7 and then again 8th value. So again when I compute the 8th value, it is same like W8 0. When I compute the 9th value, it is same as W8 1. I compute the 10th value, it is same as W8 2. 11th value will be same as W8 3. Why these values are same? Because just now we had seen that it satisfies the property of periodicity. So twiddle factor is periodic in nature. So there is no need to compute again all the values. As you can see here, if I go on computing the values here, I can go on and on and on, but all these values will be repeated and repeated. Okay, so that's why this is a periodic, it exhibits the property of periodicity. Therefore twiddle factor is periodic in nature. So once I compute all the 8 values, I can go on writing it like this: is equal to, is equal to, is equal to these values. So these values will be same. So only these 8 values will be repeated, shown by the red box. So only important thing is that we have to compute these 8 values. Another thing is, what is the symmetry property? Now what is the symmetry property? If you see this, we have drawn a bubble here. Exactly opposite to this, we are having bubble here. So what is the difference between these two values? Okay, what is the difference between this value and this value? There is only a difference in the sign. Here it is plus 1 and here it is minus 1. Similarly, if you see this opposite diagonal, so every diagonal elements, if you see here on this circle, so here it is 1 upon root 2 plus j 1 upon root 2. So now here it is same thing, the value is same, only here it is having minus sign. Similarly, here it is minus j. Okay, here it is minus j, it is plus j here. Okay, here it is minus j, here it is plus j. So here it is 1 upon root 2 minus j 1 by root 2, and opposite to this you are having the value as minus 1 upon root 2 plus j 1 by root 2. So this is called as the symmetry property of twiddle factor. So these two properties are very important. Twiddle factor is periodic in nature and twiddle factor exhibits the symmetry property. So here it means that only 4 values if you compute, we can get the other 4 values. So this becomes so much easier. Hence it is very easy to compute the twiddle factor values. This twiddle factor is a very important factor. We will be using it to compute the fast Fourier transform. So similar interpretation you can go for 4-point DFT. You can compute the 4-point DFT. For this was for 8-point, you can compute it for 4-point. Okay, we will continue with this discussion in the next lecture. Thank you.